So, thank you very much for coming along. So this is a presentation that I originally gave on Thursday the 12th of May, but I didn't record it, so I thought I'd give it another go and just to try and help record it basically. So welcome to Can a Machine Read the Delius contact log better than a human as part of the Insights Festival. So just as people were joining, I asked some people to tell me on Slido what organisation they work for. So we got a lot of people from data and analysis and MOJ, two different recordings here. A lot of people from HMPPS and the probation service, but also good to see some people from Cambridge University and Oracle in the private sector. I was also keen to get a view of the kind of people that were coming profession-wise. So we had a lot of data scientists, and we had other analysts like operational researchers, social researchers, people that consider themselves data hobbyists. So that was good. But we've also got probation officers, technology consultant, and people, just general public sector leads. So it was quite a good mix. So yes, welcome to Can a Machine Read the Delius contact log better than a human. So the agenda for today is I'll explain or just introduce who I am, then introduce what Delius is, which will be the focus of today. I'm then going to talk about event extraction and the motivation behind the problem, then talk about how I'm going to do it, and then hopefully, if it all goes well, give a demo of that. So I deliberately, with the help of a colleague, came up with a controversial title in the hope that it would draw people in to come and see the talk. However, the actual topic for today is really event extraction, and it's using machine learning to automatically extract events from free text. So as a spoiler to the original question, no, not yet. Humans will not be replaced by computers. But I would say that I hope at the end of this, you'll see the opportunities that there are to use computers and machine learning to help in, say, summarizing text is one use case. So back to today, who am I? And I've waited quite a while to say this. So my name is Andrew Craik, and I work at the Ministry of Justice in the Data and Analysis Directorate. I work as part of a probation data science team, and we're actually part of a larger programme of work as part of probation reform. And within the probation data science team, I am a lead data scientist. So very quickly, when you hear data scientist, just hear data analyst. But we are preoccupied with predictive modelling and machine learning, and we often do want to see our work deployed into live production IT systems. What's maybe a little different from other data analysts is the extent to which our programming skills should be, how high they should be. So some of what we do may veer into software development. And then the expectation that we'll be able to work with large and unstructured data sets, for example, applying novel techniques to really large data sets with billions of rows. And some of that might be quite unusual data like text, video, audio, or even location data and GPS. And that's it. Yeah, that's where I sit at the moment. So what is Delius? This is the next thing that's important to know. So Delius is a case management system that's used throughout England and Wales, and it will sort of record people from their journey as they enter a court, and will have information on their court appearances. Pre-sentence reports may be made for that individual. That will be requested by the court. Probation will make them, record them in Delius, and it'll also have information on offences, sentencing or disposals. And then once an individual enters the community, Delius will be used for management of the interventions, and it'll have information on appointments and things like that. But the focus of today is the free text data that's held in the contact table that is a part of Delius. So the contact table has 500 million rows of data, or documents, text documents, and these are notes from telephone calls or emails, letters. They include practitioner notes and planned and unplanned contact. And we're going to focus on that today. So the motivation behind event extraction, I'd like to explain what the motivation is. So the motivation is humans are very good at reading. We can read text and pick up subtle meaning, sarcasm, irony, and make references or connections with other texts, but we're very slow at reading, whereas computers can process vast amounts of text very quickly. but actually it's not trivial to get a computer to extract any meaning from that. So the objective is to automatically extract events from the case management system Delius. So the first thing I had to do is actually define what an event was. So I don't want people to laugh, but I did actually Google what is an event, and it kind of really focused my efforts on like two sort of phrases I've put here at the top. It's in any sentence where someone does something or where something happens to someone. So this seems very vague, but at the heart is an action or a verb. So in this case, it's the something or the something that's happening. And I want to know what that verb or action is like to a person or thing or someone. So just to take some examples from the news at the time I did the presentation, EasyJet to take out seats so it can fly with fewer crew. So here I happen to know that EasyJet is a company. The action here is that seats have been taken out, and I understand that the importance of the fewer crew is that it's a money-saving exercise. We've also got the Bowie music event will be staged in a planetarium. So here, the action, the thing that's happening, is the staging of the music event, staging to stage. And I happen to know that Bowie is a music artist, so I'll be able to work out this is probably some sort of concert, and we can tell where it is, the planetarium. And then finally, and sadly, there was a news article about vandals trashing a popular family bird feeding spot. So here, the action, the thing that's happening is the trashing of the area. Here, I can understand that trash is not the noun, trash or rubbish, but actually the verb to trash. And we can see here that the thing that's being trashed is the bird feeding spot, and the people or thing doing the trashing are the vandals. So we do this relatively easily, and what I'm going to try and show is how we can get a computer to actually do this. So I'm going to work with an example sentence. Andrew is presenting at the Insights Festival in May 2022. And at the heart of what all the next things I'm going to talk about, I want to understand what is happening, who's doing the what, when is it happening, where is it happening, and beyond the scope of today, but it's something that many people have talked to probably know about, it's about sentiment or positive or negative sentiment. So very much what I'm talking about are these things where, what, who, and when, and why, maybe not why, but something I'm not going to cover. What I wanted to mention was some people use machine learning to basically get a computer to classify whether or not that sentence has a good or positive meaning or not. In this case, I'd hope you would agree it's positive. Okay, so with that sentence in mind, we're going to have a look at how I'm going to be able to do this. So surprise, surprise, the how will be with machine learning, and I'll be explaining in these three concepts here. So before you get scared and think I've gone off and developed all these machine learning models myself, I'm going to be leaning very heavily on a thing called SPACY, which says they've got industrial strength natural language processing, and it really is incredible. In short, they've written code and then trained models which allow us to focus more on the problem rather than like solving the problem and enjoying that process than having to work out really complicated mathematics and machine learning. So I'm very happy to have that here, and I can't talk highly enough of this. So very quickly, I'm going to just explain a little about the machine learning because it's at the heart of these three things here, and it's the concept of supervised machine learning. So when we talk about supervised machine learning, I'm talking about supervision in the through examples. So what we do is we give the computer lots of texts and we tell it what we're looking for, and humans will have to do that. And what will happen is the learning comes in the shape of the computer making a guess. It will check its answer against the labels that were given, the examples, and then it will try again, constantly changing how it answers to try and get better results. So examples of more simpler ones are things like spam detection. You give a computer lots of examples of spam emails, and a human can say yes, no, yes, yes, no. And then eventually a computer can probably predict whether or not an email contains spam. That exact same problem is whether or not a tweet or any other message contains hate speech. And again, a human just needs to flag lots of emails or texts or tweets as hate speech, and then a computer can then eventually work out which words are associated with hate speech. Same again, urgent messages. Say we work in a company where we receive messages, say from our customers, and we need to try and predict whether or not it's urgent in advance. Well, again, you just give lots of examples and then a computer can probably predict whether or not it'll be urgent. A different kind of problem is maybe language detection. In this case, we don't just have, it's not just a binary thing that we're classifying, whether or not it's spam or not, hate speech or not, urgent or not, but actually we can have hundreds of languages, and some languages will be much closer than others, say Spanish and Italian. So that's a slightly different problem. But at the heart of all of these are examples have been given to a computer, and then it will make guesses and eventually, hopefully, get better at guessing. So how does that relate to what we're doing? Well, with these examples here, it's very much what happens with these three cases here. So what is entity recognition? So entity recognition is all about who, what, where, and when in a sentence. So when you read this sentence, Andrew presenting at the Insights Festival, who is doing what? Well, Andrew is presenting, and he's doing it at the Insights Festival, and the when is May 2022. So I've been able to pass that sentence to Spacey, the programming library in Python, and then it's been able to return to me that Andrew automatically is a person, that Insights Festival is an event, and it's happening in May 2022. And that's that. They've been able to train the model through lots of examples, and as people have tagged different things like geopolitical entities or places, dates, even works of art can be detected automatically. And these are the entities that have been detected in the sentence. And that's that, really. I took the other sentences just to see how it would cope, and so it's correctly identified that EasyJet was an organisation, and correctly I can't see any other types of maybe known entities. Bowie or Bowie here, it's not recognised that it was a music artist, but it has identified that it was a person, and correctly there's no sort of no other entities in that third sentence. So it doesn't always return something. So once we've identified sort of people or things in our sentences, the next one is really to understand the actions in the sentence. Probably better through an example. So we've got what are called parts of speech. So when we take a sentence, I want to know when we look at a word, what role does that word play in that sentence? So if we took every single word in this and passed it through Spacey, it would be able to return this information here. So we'll just have a quick look. So in this case, Andrew is correctly identified as a proper noun. We've got the word presenting as being correctly identified as a verb. I'll stop saying correctly. In this case, all of them were correct, I think. Insights Festival were both proper nouns. And then we've got May, which is a proper noun here, probably because it has a capital M, but if you take the word may, the computer's been correctly able to disambiguate between may, the verb, and the may, the proper noun. So here we don't care if Andrew is an organisation or a person, just that it's picked up that it's a proper noun. And why that's important is I'm very much wanting to focus on the verbs because they help us identify actions where things are happening. Oh yeah, one other couple of were the at and in, very important. These are flagged here as ADP or add positions or prepositions. Prepositions are all about time, space, and location. So here we'll come back to this, but prepositions are very important. So that's we've got entities in our sent words, and then we've been able to identify what role different words play in the sentence. And the last one is all about bringing that together to know the relationship between the words. So again, take the same sentence and we can put it into Spacey, and using machine learning, again, people have hand labeled sentences and how words related, and we can get this really complicated tree. So yeah, very complicated, but I'll explain this because it is at the heart of what I've done for this project. So taking the first little bit, Andrew is presenting. So we'll see the parts of speech at the bottom. So we've got proper noun, auxiliary, and verb. So the verb here is presenting, and I can see 1, 2, 3, 4 arcs coming out of that verb. And the direction of the arrow tells me that the parent is the word presenting, and the presenting has a child here is Andrew, and this child is the nominal subject. In this case, it's the thing that's the person or thing that's doing is the subject of that verb or subject of the sentence. So I am now able through code to take the verb presenting and understand that it's Andrew that's presenting. Now that's great, but without knowing where and when, it's not a very useful piece of information. So the next bit is to look at the other side of the sentence, and we can see that there's actually 2 preps or prepositions that are coming out of the verb presenting. So one preposition here is at, so that tells us it's probably location, and we've also got in, the second preposition in, which also could be a location, but in this case will be time or date. And we can use these arcs to actually pull out the preposition and then the object of that preposition. In this case, it's the festival. So this seems really esoteric, and I won't lie, I had to learn a lot of English grammar. But why this is important is that from this sentence, we are now able to extract 2 separate pieces of information that Andrew is presenting at the Insights Festival, and also separately that Andrew is presenting in May 2022. So what's important about this is we can now turn sort of information into knowledge, and link maybe Andrew's presentation at the Insights Festival to other presentations at the Insights Festival, or even other things that are happening in May 2022. So it's very, very powerful, and I was very excited when I actually got my head around what it was trying to do. And that's that. So with a combination of knowing the parts of the speech, the verbs, the nouns, and whether or not that noun is a person or not, and how those are related in a sentence, I have been able to do automatic extraction of events. So just to highlight again, at the heart of what I aimed to do was, let me just go back. I go through every sentence in Delius and identify verbs that are directly linked to a person. So a proper noun could be an organisation, but I use the entities to make sure it's a person. And then from that, I loop through the other parts of the sentence using the arcs to try and extract a little bit more information or to make it a meaningful sentence beyond Andrew is presenting. So that's that. Entities, parts of speech, and syntactic dependency or syntax. Cool. So let's get to the demo part of the presentation, and wish me luck. This all goes well. So I'm just going to load up the libraries and things that I needed for this. And hopefully a message appears here to say everything's going okay. Loaded up pre-trained NLP model. Okay, so I'm going to skip past these bits, but they were used for the presentation. Just to explain what I did, you can write something like sentence equals Andrew's presenting insights. We'll print it out just to check it is what I say it is. Then I can apply some natural language processing to that sentence, and then we can render or display the entities within it. And then we can see how they're related, just as we have. And then we can loop through each word in that sentence just to check that, again, what I showed you in the presentation is what's happening. So at this point, I did open up to the attendees, and I was given a test sentence, and I was given the pigeons are stealing all the peanuts from my bird feeder, which I thought was unfair because a pigeon, well, they are birds. So what I did was took the word pigeons stealing the peanuts from a bird feeder, and then we tried to render the entities and then the relationships. So this red message here was telling me that actually there were no entities found in the sentence. So pigeons, while they are a noun or a thing, they're not like a recognized, like can't link it to say a Wikipedia page about, you know, like, unless it was a famous pigeon. So that's kind of why that's come up. But what we can see here is the relationships between the words. So verbs are always really, really important. So what we've got is the verb stealing. And really what you often find is that the verbs in the sentences do not have any arrows pointing to them because they are at the head of the sentence. So here we can see that the stealing verb has the nominal subject pigeons. So now I know that the pigeons are stealing. And in this case, we've got the object, I can't remember what DOBJ is, but it's the object of that verb, and the preposition they would give us information on location, space, is from. So stealing, from, and the object of the proposition is bird feeder and compounds. So here we could just get pigeons stealing from bird feeder, or we can actually get from that stealing peanuts. So again, there's two bits of information. Pigeons are stealing, and we can separately get that they're stealing from the bird feeder. So this, again, I just can't go over like how you can give lots of different sentences, and it tends to do really well, I think, at understanding the relationships. What I'll say here is I don't always know what all of these are, like DOBJ. I've obviously paused on that. Predeterminer. A determiner is just like the word the, I think. And pos, don't know what that is. Possessive, yeah, my bird feeder. So that was an interesting example, actually. So what I'm going to do now is go back to Delius, and I just want to show using some real-like data. So I'm just going to highlight this is not real data, but I've used some real elements of it in order to get some real structure. So this is all contacts for one individual, and there's 150 of them, or 147 documents that were recorded. So just to give you a sense of what the structure of this data looks like, this is it here. So we've got, I think, all the contacts for this individual going from August 17 all the way through to August 2019. So the height of a bar just tells us there's a lot of contacts happening at that point in time. And this in each blue dot represents a unique contact. So I'm going to zoom in just to get to the start of this person's journey. And what it's started off as a court appearance in August, and then a pre-sentence report was issued or requested. And then, so what I should say is that each blue dot represents a contact. Each vertical panel represents one type of contact. So court appearances will always appear here. So the way I often look at this is a blue dot and then look across the way as I understand other activity that happens at the same time. So this individual I happen to know was sent to court for drink driving. So there's a court report requested, and then at this point the individual was sentenced and found guilty and was given a community order. Then there was a flurry of activity, including phone contacts. Then the community order was commenced. They were given risk assessments, and then there were some emails, and then there was lots of planned visits and phone contact. So we've got phone contact from and to the individual. And then we can scroll through time and see that here planned office visits were the most important, not most important, but most common thing that were happening. And yeah, this is all contact for one individual. So we're going to look at what a note would look like. I've kept the structured one, but all names, details, locations have been changed. So that was actually one of the hardest things of preparing for this presentation. So this is what it looks like. I'm not going to read it all, but action, contact with social services, next appointment with either Laura or Audrey, depending on Laura's return. And then here the name Christine, that's the important name. This is the made up service user. So Christine's brother has 4 children. He's split up from his wife Donna. Donna's attempted to commit suicide. As a result of this situation, all the children at various times have stayed with Christine at her mum's house. So I won't read it all, but what we want, what I was aiming to do was try and get things like this and extract sort of summarized events from it. So what we're going to do is take that note and apply the NLP to it, and then we'll have an NLP document. So you won't see anything here, but let's just see what the entities look like for this. So going through every single sentence, Sentence 0 had no entities. Then sentence 1, next appointment with Laura or Audrey, had Laura, Audrey, and Laura were all correctly identified as entities or people. What we can see is that there are some problems with it. Leslie Ann has been identified as an organisation. The children's ages have been identified as dates. And it doesn't, for some reason, Christine here was not picked up as an entity, whereas every other case it was. So it's interesting that, to me, even now looking at it, there are some points at which, oh no, it was actually Christine at her mum's house. It was picked up. I'm just reading the sort of raw sentence, and then that's the one with the entities. Yeah, so it did better than I thought. So that was just looking at all those sentences in that document here and seeing what the entities were, which will come into play in a second. So what was the logic that I was using to apply to and extract an event? So let's take one of the sentences. In this case, Donna attempted to commit suicide last Tuesday. And we're going to look at the relationships. So what I did was wrote code that would look for any verb that was directly linked to a person. So we could take the verb commit and look through each arrow and then look for a proper noun that was a person. So here commit was linked to Tuesday, but Tuesday's a date, not a person. Suicide's a noun. And so in this case, there was no direct link to a person, but then the verb attempt was to attempt. Yes, it's a verb. I have to question this. So the verb attempted here is directly linked to Donna, proper noun, which was identified as a person. So there we go. I now know that Donna attempted something, and then I've written some logic which will iterate through different arcs in order to try and extract meaningful sentences. So not just Donna attempted to commit, but try to extract other parts of that sentence. So with that logic, just going to run it on all of the 147 documents for that person. And let's take the sentences, the original document that we've just looked at, and see what events we've extracted using that logic. So we've got 7 events from 0 to 6, and they are: Christine attended on time, Marco has 4 children, Donna attempted to commit suicide, Marco tried to contact social services, Christine's feeling the pressure, and so on. So what I then did was just to try and prototype what this could look like. I have taken for every document, in this case there were 7, and I didn't want to show all 7. I've taken the longest one and plotted it in a sort of timeline to try and show what it could look like operationally. So here we go. So from September, we've got each circle here represents an event that was extracted. So let me just zoom in. And it starts off with Christine called to make an appointment. Christine signed data protection form, GP consent, and was given paperwork and leaflets. Christine has had an initial interview. It then goes on. Christine does not want BB accommodation. That'll be bed and breakfast. And we can scroll down, keep going. Sam will call me back. So that's phone contact. Sarah wrote to Christine to ask whether she was okay. Please do note that none of these dates, people names, any locations are real. Again, Sarah wrote to Christine to ask if she was okay. Christine understood this, but was not good at seeing things that could go wrong. So it's not really clear what's going on there. Christine following behaviour from Trevor and fleeing home situation. Christine seemed to be in good form. So let's see, I'll just zoom out. And then we can go further down the bottom, and Christine is doing very well with Learn Direct and Leamington. Order now completed, terminated on goods of ground progress. And there we go. So this actually had a happy ending. This individual's order was terminated. So what it is really to show that we started off with all of these contacts here, and we've been able to sort of summarize it down into like a timeline like this, which would help hopefully summarize the individual's journey. And that concludes that part of the presentation. And I'll just finish it off with going on to some of the questions that I was asked. So these kind of centered around what was the operational use for this. So I explained that the idea behind this was to allow a probation practitioner to select an individual, and then for the computer, rather than just present them with like hundreds of documents to read through, just to try and extract some of the points that were maybe happened and produce some sort of automatic timeline. And good question I was asked was about important events. How do we know whether or not the right things were pulled out or what was the most important thing? And so what I said was, well, how do you define important? And just as we've been able to train the computer to look for nouns or understand how words are related or entities, we could also train it to look for what we class as important. So if you think about the examples in the machine learning, I think it was, urgent messages. So maybe just analogous to what an urgent message is, we can consider what's the important messages. Bias. So what kind of bias might be creeping in? So I said in answer to this, there definitely would be bias because these models were trained on specific types of text and they're not built for necessarily just this text. For instance, social services weren't picked up as an organisation, perhaps because it didn't have capital social services, but deliberately I had chosen something which wasn't, chose a presentation on using machine learning that wouldn't be controversial in the same way of like using the contact log to determine whether or not someone gets to terminate their community order, but rather been more benign in that just trying to summarize some text. Another question was about, and we did discuss bias a bit more. This was kind of something I think some people were a bit more, as always, and rightly should be concerned about the use of machine learning. And then last, somebody asked how Delius handled, not Delius, sorry, the question is here. How does the model deal with typos and or abbreviations? For example, what if an organisation isn't typed up with capital letter? So here I wanted to highlight that the models haven't been trained to look for all names, but just to guess in the context that a word is a proper noun given the context of the sentence. So if I were to make up, let's see, a sentence with a verb that doesn't exist, let's see, made up, I will quickly, and I will, so woo could be a verb. I will quickly, and then we can see doc some NLP on the made up sentence. And then we just want to display the entities. Oh yeah, I want to see the parts of speech for this. So in this case, I'm trying to show that woo might actually be a typo, or it might be actually, I might be speaking in some sort of slang. Oh yeah, sorry, I need to pass this. So in this case, unless I'm incorrect, but woo, it thinks that woo is a verb. It's never seen woo, but it thinks it probably is a verb, even though just given the context, you know, I being a pronoun and quickly. So yeah, like I'm sure there's other cases like Apple, the organization. I want to buy an Apple phone. Let's just see how this handles this. We'll try the entities and see if it. So no entities were found. So in this case, unless the Apple, in this case, it will not correctly identify the organization unless it does have a capital letter. But in some case with the woo as a verb, it did actually handle that okay. And so yeah, that's concludes the presentation, and just like to thank you for watching, and do get in touch through the Ministry of Justice if you are able to. And my name is Craik. Okay, so thank you very much.